Our next speech is again reserved for the platinum partners of this year's conference, Bosch. Presenters are Vitomir Jovanovic, who is Senior Data Scientist at Bosch, and Katarina Arandjelovic, a Junior Data Engineer at Bosch. In their presentation titled Enhancing Text Classification and Prediction Models for Complex Construction Industry Data, they will discuss their approach to classifying diverse texts in construction industry tenders into over 100 categories. Utilizing a fast text model with customized embeddings and strategic probability thresholds, they have effectively tackled the challenge of predicting product and supplier categories, achieving high accuracy and F1 metrics. Additionally, the presentation will cover their unique methodology for product prediction using fine-tuned BERT models and the potential for future improvements through deeper domain data insight and rule-based approaches. And I welcome them to stage to help me out with all these terms.
Okay. Good afternoon, everyone. Thank you for being here and for your interest in such a fascinating area of data science, particularly the realm of natural language processing. Your presence today underscores the importance of understanding and exploring the ever-evolving area of natural language processing within data science. My name is Katarina Arandjelovic, and I'm Junior Data Scientist, and today I will present together with my colleague, Vitomir Jovanovic. So let's embark on this journey together. Thank you for being part of this discussion about NLP, and I hope that by the end of our time together, we will walk away with some valuable knowledge and perspectives about NLP and how it reshapes the landscape of data science. So today, we are embarking challenging tasks, organizing many different texts into more than 100 categories related to construction tenders in building industry. Our data comprises an extensive collection of over 1 million tenders centered around texts centered around these construction tenders, spanning across more than 100 categories and engaging a network of 250 suppliers. What makes this task particularly demanding is granularity of each tender, which comprises around 300 positions and which takes a lot of manual work to fill up one tender document. Within each tender position outlined in the tender, our specialists at thermotechnic department are tasked with selecting from a wide range of choices, which is 250 different suppliers, 150 different categories, and a huge selection of 36 possible products. This intricate decision-making process heavily relies on extensive expertise and on in-depth knowledge. Complexity deepens when considering the challenge of transferring this extensive experience and also our experienced team members who have been within TT for over 10 years find it hard to transfer this intricate knowledge to new team members. Also, retirements are coming, so preserving and transferring this extensive knowledge becomes an urgent concern. Realizing the importance of the challenge, we conducted through user testing to understand what our team works and what they really need. The TT team, which is thermotechnic team, made sure to carefully document each tender and each offer and its corresponding prediction through the years. Then we are following these consistent rules. We created a strong MySQL database in order to not only to store this data, but also to prepare for future model retraining with new data. Understanding how business works is the key. Without that understanding, it would be hard to solve any of the issues properly. After that step, we created new rules and features based on this existing business flow. This is the key idea. Knowing the technique is important, but understanding how business works is the key to make the solutions to work well and last. On this slide, here are some examples of tender positions we may encounter. We have chosen shorter ones with simpler requirements for broader audience. Also, they have been translated into English for clarity. As you can see, some texts are really short, so this lack of details can produce this classification task challenging. On the next slide, you can see the original tender positions in German. As you can see, they are rich in details, presenting the challenge for those who are not experts in the field to classify them and also visualize them. As you can see, in first example, the device for horizontal mounting is needed. You can see it in the last sentence of the first paragraph. If vertical mounting is required, completely different product should be recommended. Also, we can have some operating pressures and temperatures which are required for some device, and small differences in these parameters can completely change the device and system that should be recommended. Our task is to predict whether the company can provide an offer, determine the supplier, determine also the product category, and a specific product that should be recommended. We used several models for our prediction. First is offer model, which is a random forest model on retrained fasttext embeddings, and it predicts binary outcome whether the company can provide offer for this tender paragraph. Next, we have a supplier and category model, which use the fasttext model, and they predict supplier and category of the product for this tender paragraph. And the last is the product model, which is by encoder, which is fine-tuned BERT, and it predicts the final product on the tender. Our data are available for 6 regions in Germany, and initially we experimented with different approaches, and we tried with some global models, but best results are achieved for models which are trained on data, on region-specific data, except for the product model, where we have one global model for all regions. So, in total, we have 3 models per each region and 1 global model, which gives a total number of 19 models. In the initial stage, user needs to verify the AI prediction to determine if each paragraph aligns with the company's offering. Once confirmed, the AI prediction narrows down the number of paragraphs for supplier and category model, focusing only on those which are indicated as offers. Once we achieved accuracy around 80% for supplier and category model, we decided with our product owner to increase the fasttext predictions to the top 3. And this adjustment resulted in accuracy around 19%. To ensure accuracy and to avoid error cascading through the model, we extensively involved users in in different stages. For instance, that's because, for instance, if we have the first model, which filters tender with accuracy around 80%, and then we send these tenders to another model with the same accuracy, the total accuracy tends to decrease and to be around 64%. And to handle this, we involved users in different stages and also implemented user confirmation step after the first model and before sending to another model. And the last is the product model, which, as I said, predicts the product that will be recommended to the user. Now, my colleague Vitomir will share more about what we achieved and the challenges we faced.
Thank you, Katja, a lot. I will try to go briefly through challenges we met on this, let's say, road of making those text categorization. The first thing is that we basically had a very complex system of many different sources and data lakes. Around, I think, 30 people works only on, let's say, maintenance of those tables, and it is really domain specific. And one solution architect joked that they are speaking Saplish because those are maintained in SAP. So it was really hard to understand them and have that knowledge for the, let's say, short time. The second problem is basically we don't came from the building industry, and we basically are not experts in those products you saw. Those are very complicated ones. And also the problem was that a lot of tender paragraphs are very similar. They only differ in some attribute, let's say dimension, radius or something. So we afterwards had to build a special algorithm that would solve this issue. And the last thing, and maybe the most funniest, is this kind of late inputs we got. That basically means that you don't know what you don't know, and the others don't know what you don't know, and you are unaware of some resources that are there and that you can ask for, but fortunately we solve this by, let's say, regular meetings with the users. So our advice would be that if you're building some applications, you must have this kind of user interviews, user groups, and understanding what users do, especially in this kind of, let's say, expert system that we built. And let's speak about achievements from this POC where we got 60% of accuracy. We raised, in average, our models to 80% of accuracy, having in mind that the number of labels was huge. Suppliers are 256 labels. I think those accuracies are quite high, or even we couldn't do, let's say, better than this. And how we achieved it? We basically tried to relabel the suppliers in some categories. We noticed that there is a lot of suppliers that are appearing only 5 to 10 times in 5 years. So we wanted to merge them with some more frequent ones. Also, what is maybe the most important thing, we in the fasttext created customized embeddings, meaning that those word representations were more sensitive to the industrial context. Also, we decided that we will not have one global model, and that we will reduce the noise if we split the data into 6 regional models, because there is no reason that the same suppliers will be in Hamburg or in Mainz. So also we were setting the new probability thresholds, which is, let's say, more thinking in odd ratios, something that we do. And also we created a new offer model. And here you can see the comparison of different offer models. This model basically predicts whether the tender paragraph you receive can be offered or not. And here you can see that those models with customized embeddings outperformed the initial fasttext model that is in red. That was, let's say, initial model. And also we see that always the models with embeddings, with these customized embeddings, outperform models with more simple vector representations such as TF, IDF. And basically, you can see that accuracy was from 91% to 96%. And it was, let's say, a dependence in regarding the quality of the data per regional level. Why I want to say this is that fasttext showed a really good performances on this, let's say, multi-label classification problem. It is basically neural network with one hidden layer. But what is the specific is that it uses this hierarchical softmax function in contrast to regular softmax function, where each node is one label. Here are the labels are structures in a 3 structure, and the model traverses and makes a decision at each level. So it really computationally is effective, and I think it also has the impacts on the accuracy level. And here you can see the numbers that, for example, it was from 80% and 87%. Also, we are always putting F1 because the data were not balanced in a perfect sense. And supplier model was about 73% to 83%. And you see that the model with a lower number of labels were, let's say, weaker than, stronger than the supplier model. And I think let's say, the most important lesson learned is that you should use customized embeddings whenever you can, because you have some, let's say, in the fasttext, some pre-trained embeddings on a German language, for example. But basically, I think it is a good idea to try several options to play a little bit with it. And we tried various options. From the number of skip runs, we also used the subword level, and we played a lot, and we find some, let's say, optimal hyperparameters due to this context of the tenders where some words are going together all the time. And I will not go, let's say, into it, because I think, but I would say for someone who is a beginner and wants to start to learn natural language processing, I think this understanding of what is word representation and word-to-vec and both models, skipgram and continuous bag of words model, are, I would say, the most important thing as the first step to that. And regarding, I would say, the most complex problem, and our colleague Feng Zhe worked a lot on this. This is basically by an encoder product retrieval solution. It is basically dense passage retrieval model who serves usually for question answering. And briefly, I don't have time to go into much details here, is that basically it uses some pre-trained large language model such as BERT, and then we are again doing the fine tuning, meaning that the inputs, let's try to describe the inputs. Inputs is one tender document and one tender paragraph, what is needed, and the product description for that particular product in our database that was matched to this tender. And then they are going through this encoder, and we are making, let's say, vector representation of both tender paragraph and product encoder, while we have some, let's say, in-batch negatives, those negative examples which are labeled as zeros, and those pairs are labeled as ones. And then basically we are doing the tuning. And also, if maybe for easier understanding, is that the objective function that we optimize is basically trying to make the similarity between these two word representations maximal as possible. So this is the objective function that by encoder models want to learn. And then, this is not the end, then those vectored representations are stored in something that is called FICE. I'm not sure how to pronounce it. It is basically Facebook AI similarity search. They're stored in this kind of indexed database, and basically you are not doing the prediction. When the new tenders come, it basically searches the most similar vectors to those input tender paragraph. And basically for top 30 of those vectors, the accuracy is 70%. That basically means that if the product, real product is in those top 30, it means it is accurate prediction. Maybe it seems it is not so impressive, but having in mind that you have 36,000 of different products that are different in really small amounts of descriptions, I think it is good. And we are still doing to try to filter this initial list of predictions to some smaller set of numbers. And here you can see how our demo applications looks like. Basically, here are the tender paragraphs, those text, and you can see those green, yellow, and red. It means basically that green is the most probable supplier that is recommended for this tender paragraph. And if it is gray, that means that it is not an offer. And we tried to make this model independent because we wanted to avoid error propagation. We didn't want to couple the models. And for the end, let's maybe just see some advantages of those fast text and by encoder. Well, for fast text, I think it is very easy to adjust the top N predictions. And it shows a really useful feature for our problem, because if there is a lot of labels, it is the top one accuracy will be low, so this parameter is really important. Tuning is really easy, but I would say that we made major improvements by data cleaning and those label merging and so on. Also, fasttext gives you the opportunity that you can create new embeddings, as I said, and also it is very easy to adjust the probability thresholds for the predictions. You can see here the code is really simple. But what is the, let's say, downside? it is that we noticed some unexpected behavior without some adequate or expected logging. The model came to some special characters and it stopped training, but he didn't give us the information that it stopped, so we figured it out this, let's say, unexpectedly. And also, this adaptation of some libraries are not, let's say, available to average data scientists to go in C++ and make those changes. And regarding bioencoder, it is really possible to solve complex problems. And basically, this is large language model that can be adaptable by this, our approach to, I think, any business problems when we have some kind of a pairing of the two texts or something like this. The downside is that basically it is almost impossible to train it with a GPU. For example, for 8 GPU cluster, it took 10 hours for training. And also, it is not able to discriminate those small differences in the text. Also, it is quite large, so this upload on our server is quite long. And I would say the best thing for the end is our team, and it was really nice, really nice experience to work with them. I want to mention them by name. In the backend, Ana and Voja, frontend, Lazar and David, DevOps, Nikola and Raghu, AI, Feng, Katja and me, QA team, Zoki, Dražen, and our, of course, solution architect, Werner Fuchs, and project manager, Emilia Dobis. Thank you very much on your attention.
Okay, so to see if there are any questions first. I may have a question. I mean, my question would be, who do you see as probable user of this? I mean, when you were creating this, who did you have in mind that will be main user of this?
Yeah, basically, we know them personally. Those are the guy in Bosch who works with a lot of tenders in a week. They spend, for example, I don't know, 1 month for one tender, and I hope now it will be a 1 day for
so it is tested with him?
Yeah, yeah.
And can it be used for different tenders? I mean, is it difficult to change it for?
If we have a new data, it wouldn't be difficult.
So you think that this system that you created can be adjusted, not only for this was for construction industry, so you think that you can adjust it for any other industry?
Of course, yeah.
Okay. Has that opened any questions for anybody who wants to join on tender and get his? I mean, I can tell you that's one hell of a task. I mean, working with tenders on both ends. Don't ask me how I know that. Okay, if there are no questions, thank you, and let me give you certificates for presenting on Data Science Conference, and thank you.